Welcome to the Heat Pumped podcast. Heat pumps are a powerful tool to decarbonize buildings, and the cool thing about them is that they're a mature technology that can be deployed today. But that's easier said than done. There are still lots of challenges to installing heat pumps in every home, and solving these will take everyone from homeowners to technicians to policymakers. On this show, we'll bring together the smartest people in the space, working to share ideas on what's working and what needs to change as we work towards installing a heat pump in every American home. Whether you're a homeowner looking to install a heat pump, a policymaker crafting programs to incentivize them, or a contractor who installs them every single day, I think there's something here for you. I'm your host, Shreyas. I run a contracting company called Vayu that installs heat pumps across California. For this very first episode, I chat with my friend Nate Adams about my own background and how I got into the industry. We'll hear more from Nate soon, so make sure you subscribe on your favorite podcast platform. If you like what you hear, you should also check out our newsletter at heatpumped.org. I hope you enjoy it.
So you have kind of a wild background. I mean, you come from literally being a rocket scientist, and now you're in the heat pump world. So what happened?
Yeah, it was all an accident. And to be honest, when I first found out about heat pumps, I thought they were the most boring thing in the world, and I wanted nothing to do with them, which is probably the reaction that a lot of people getting into HVAC have. But I had a friend that was talking a lot about them, and he kept hammering me on heat pumps and how they're great for the planet and they're this really cool technology. He loved solar and renewables, and he thought a lot about how we can electrify buildings. And it took me a while. It took a lot of him to keep bringing it up again and again and again until I finally decided to dig in and see what the fuss was about.
I read you actually dig in.
Yeah, I think it was probably the fifth or sixth time that he said the word heat pump, and this was probably over the course of 2 or 3 months before he finally hammered me enough for it to me to dig.
So what year did you dive in then?
So this would have been a couple years ago. I think it was 2022. Yeah. And I started looking. He sent me this long, boring journal paper from like the National Institutes of Science or something. And it was like refrigeration cycles 101 and how to model them on a computer. And it was like one of those like classic 70s tech papers that has these like hand-drawn diagrams and like clearly printed on a typewriter and someone scanned it in the like needs when they were digitizing government records or whatever. So that was my start.
So how'd you turn the corner on that? Because like I know that from like building science is something that I've dug into through the years. Like building scientist doesn't mean anything. Like there's no certificate or anything for that. But as soon as I start talking to people about the stuff that I do, their eyes glaze over and they're looking for who to talk to next. So that's part of why I picked the name House Whisperer, because people are like, what is that? And it's like, it's funny. It's this mix of magic and applied physics.
And for most people, it feels like magic. And it really is magic, right? Like a heat pump is 300 or 400% efficient. Like, how is that, right? Like, it's magic.
Makes no sense. Magic. Yeah. It's like, do you want me to explain the refrigeration cycle to you, which you really don't care about? Or would you like to just know that this is modern magic? Because it is.
But it's funny. It's funny because that like boring 1970s tech paper was like the best possible way to hook me, because a lot of rocket engineering is still built on NASA tech papers from the 1960s. And I have this big stack beside me on my desk of binders of like these NASA technical reports. And they're all kind of in the same style. They're like these typewriter, like 1960s, like someone like somehow measured all of this science by hand and like put it all together. And I think that's what stood out to me was like, it was pretty much like from a fundamental standpoint, like identical. Like I could have been reading like a paper about rocket engines. And like, when you think about it, it's like, it's heat exchangers, it's tubes, it's like all of the things connecting them. It's a bunch of heat transfer. Like, the science is like pretty much the same, but like very different application.
You don't say. So where did you work before you started all this?
Yeah, so most recently I was at a small rocket company called ABL Space Systems, and we did everything. I pretty much did everything from like the first prototype rocket engines to putting them on the test stand in Mojave and like test firing them. Dealt with a bunch of engines that blew up. Like I brought like transported rocket engines in the passenger seat of my Miata to like bring them back to the factory to rebuild. Like fun stuff. We were up in Kodiak, Alaska, like actually assembling the rocket to launch. And so, yeah, lots of fun there. I was at Blue Origin before that, SpaceX before that. So I've been doing rockets for a while.
And then all of a sudden now you're in the HVAC world.
Yeah, I'm going to be honest, Nate, like I think this is a harder problem than rockets. And I think that's what really got me, because like when you're thinking about designing a rocket, you're designing for like every engineering problem, you're like designing around some constraints, and like there's a constraint that is like the most important thing. And for a rocket, it is like lightness and reliability. So it only works for a short time. You need to make sure it doesn't blow up in that short time. All of your parts are really light. And so those are the big constraints. And so you end up working with these really exotic materials. You do a lot of analysis around like the strength and their reliability, like make sure that your blades aren't going to blow off when they're spinning at like 60,000 RPM. But like that's the challenge for a rocket. But for a heat pump, it is constant mass adoption. Like I think one thing that is really cool to me is like a compressor is like a couple $100. It's insane because like fundamentally that's very similar to like the turbo pumps that we had on our rockets, and like each of the turbo pumps I worked on was like $300,000 or $400,000. And so it's like fundamentally it's like spinny bits and
different.
Yeah. And so like that wowed me, right? It's like this is really cool. This is like a very different challenge, and I think it's like 100x harder challenge to get heat pumps in hundreds of millions of homes across the country than it is to get a rocket to fly. That's just me.
No, I 100% agree. I mean, the curse of heat pumps is that adoption of them is a human problem, not a technical one.
Yep.
And once you get comfortable with it, like I happened to run a load calc on this house, but the house next door, I didn't run a load. I just put 1.5 tons in, 600 square feet. I'm like, hey, if I have to fix the shell, I'll fix the shell. And if I don't, I won't. And I didn't have to.
Right.
So once you're comfortable, it's okay. But then you have to get your clients comfortable. So I also think of Princess Bride, when he's doing that poison mano a mano thing. So fools, you've made one of the greatest blunders. That's a second only to getting into a land war in Asia. And I very much think of heat pumps as a land war in Asia, because there's 100,000 HVAC companies out there, and there's 100 million homeowners that have to be individually convinced.
Yeah.
So
and most of those homeowners have no idea what a heat pump is to begin with. So you're starting at like -1.
Exactly. I mean, 80 to 90% of replacements are emergencies. So the furnace and the air conditioner went out. They don't really care about the quality of heat or cool. They just want it. It's missing.
Totally.
So it's a crisis and their hair is on fire. So yeah, I'm with you. It's challenging, but it is kind of crazy to think that this is a more difficult overall problem than rocket science.
Yeah. But I think one of the like the cool things about it though is like when you go back to first principles, like these are solvable problems. The technical challenge is solved. Like I don't have to go and design a heat pump that can heat a home across America. Like pretty much 100% of homes in America, you can design a heat pump system that will work for them. Like that is like period. Like that's not like up for debate. That's just fact. And so then it's like, how do we figure out how we get those systems in there effectively? How do we work with the like labor available right now, with the contractor base that's available right now? Like, how do we dummy proof this? How do we make their life easier? How do we make the economics better? So when the homeowner looks at it, they're not thinking about, oh, this is this premium thing. I don't need the fancy, shiny, like Maserati of HVAC. I just want like the Toyota, right? Like, so, and like, I think all of these are solvable problems, but have not been solved yet. And so it's like exciting to be a part of that.
And here we are, some random guy from Cleveland. And then oddly enough, you went to, was it high school close to me?
Yeah, I went to high school in Canton. So Central Illinois boys, just Central Ohio boys, just.
it is funny how it can be a small world sometimes that way. So, but yeah, I
Yep.
wanted to know your story too. So that's kind of wild.
Yeah.
But I'm with you. Like the more I dive into the challenge of mass adoption of heat pumps, the harder I find it. And the only easy button I know of is like I'm well known for disliking policy, because 100% of it in my world has been counterproductive. Not like 99%, but actually 100%. I can find a problem with any program, and so yeah, I just don't like it because it makes my life harder in every case.
Yep.
But the only true solution to this that's quick is policy, which is making every air conditioner into a heat pump, which is a very small change. I mean, it's a couple of parts and it's 100 to $200 worth of parts at the manufacturing level. And then at least every system from then on involves a heat pump. It may not be heat pump only, but that's okay. But yeah, that's the challenge. But that's the only easy button that I know of. Everything else is a land war in Asia. Just pick which fronts you want to fight.
Right, right. And I mean, I think the naivete part you touched on a little bit is so true, because when I started in this space, I was like heat pumps, how this, like, I'm a rocket scientist, like this is easy, like clearly like everyone in this space is just dummies, and you just got to bring in a genius like me, and then we'll have it solved. And I think a lot of people like get into this space with similar feelings, but like the deeper you get into it, the more you realize there's a lot of skeletons in the closet. There are a lot of challenges that don't appear at face value, and like you said, I think policy will play a big part in that.
It's going to. And again, it's a human problem much more so than it's a technical one, which is surprising when you first dive into it because you think it might be a hard technical problem. It's not.
Yeah, it's like 100% of houses in the U.S. can be heated with a heat pump alone. Like,
Yeah.
I don't feel like I'm lying when I say that.
No, I mean it'll be edgy in some cases, but it's very doable.